karate.
Yeah.
Your belt.
Yeah, you are trained. I think we had one.
Aerospace engineers have missiles.
We do.
Okay, fine.
I think we had one other professor say that they were. Yeah. Hi, I'm Max Williams. I am a senior in aerospace engineering. I am here with Dr. Spulak. You want to tell us a little bit about yourself?
Sure. So I'm Dr. Spulak. I'm a relatively new assistant professor here at UAH. Just came down here last fall. I was coming from Ohio.
This past fall.
Yes, this past fall, so fall of 2022. This is only my second semester here at UAH. I was coming from Ohio, where I got my PhD at the Ohio State University. So I'm definitely enjoying the winter down here in Alabama compared to Ohio. It's been very nice to have 16, 70-degree days in January. The tornado warnings in January not quite as nice, but they're something I got to learn to live with, I guess, down here.
You went to the Ohio State?
The Ohio State University, yes.
So I hate to tell you, but I'm a Florida Gators fan, so we'll see how this interview goes.
Uh-oh.
Okay, so we'll start off with what I believe to be the easiest question. Do you prefer coffee or tea?
Definitely coffee.
Coffee? Why?
I don't know if there's really a why. I just like coffee. I never was a fan of the taste of tea, so
All right, black coffee, cream sugar?
usually black.
Black. What is all these professors? You guys like black coffee? I don't know why.
Probably because we just need the caffeine just as quickly and simply as possible, and just gotta chug it down.
What classes do you currently teach on campus / have you taught?
So this semester I'm currently teaching materials and manufacturing processes, MAE 378, as well as elasticity, MAE 672. And last semester I taught fraction mechanics, which is MAE 778.
Okay. Can you tell us a little bit more about elastics and the last one that you mentioned? I've never heard of those classes before.
Sure, so elasticity and fraction mechanics?
Yeah.
Yeah, so elasticity has to do with how materials and structures deform elastically. So when you take a material, take a table or anything, and you put weight on it, it's going to deform a little bit. And all materials behave kind of like springs. So if you have a spring and you pull it a little bit, it's going to stretch, but then you release the load and it goes back to original shape. And so that reversible deformation is called elastic deformation.
Oh, that's right. And then you hit the plastic one, right?
Yeah, exactly.
Yeah.
But if you pull that string too far, it pulls and pulls and pulls, stretches, then all of a sudden it gets bent, and then you release the load and it stays bent. And so that permanent deformation is called plastic deformation.
So there's a whole class on just that section before it becomes plastic deformation.
Yep. So just on that reversible elastic deformation.
Very cool. And what about that last one that you mentioned?
So fraction mechanics is how materials and structures break apart, particularly if they have a crack in them, which, fun little secret, every single material and structure that you come across has tiny little cracks in it. So every little beam in this building has tiny little cracks. And when you go fly in an airplane, the wings out there, you'll see them out the window bounce around a little bit, they have tiny little cracks in the wing, right? We can't ever make a perfectly pristine material without flaws. And so if you're on an airplane, and you kind of watch and, there's a little bit of turbulence, that wing bounces up and down. Every time that wing bounces, those tiny little cracks get a little bit longer, and a little bit longer, and a little bit longer. And if they get too long, then all of a sudden they get catastrophic fracture, and so the cracks just grow really, really long in a very short amount of time. And so basically things break into two pieces. And we generally don't like that to happen.
Yeah.
So we have a whole class on fraction mechanics to understand, okay, what are cracks? How do they affect the material properties? How do they grow? And how can we basically analyze structures and determine if a crack is too long or it's getting close to being too long? And so we can basically take that structure, that component of the airplane wing out and replace it with a new one that doesn't have that long crack.
Well, that is very concerning.
How tiny is tiny?
Yeah. How tiny is tiny?
So it depends. It depends on the structure and the application. So if you walk around and you look at, say, like a very large concrete pylon somewhere, you might actually see visible cracks in it with the naked eye. But if you look at, say, a component in an airplane wing, you're probably not going to see visible cracks with your naked eye. But if you look under a microscope, you'll see tiny little microscopic cracks. So it depends.
So in the negative exponentials, right? Like the size.
Usually they're somewhere down in like the micrometer length range.
Gotcha. Okay, go on.
Yeah. People in my research area are very fun with flying airplanes because we can start talking to the people about, oh, you see that wing out there? Oh, you see the fuselage? Yeah, there's all these tiny little cracks.
Yeah, I would not want to be on an airplane with you. And I'm an aero major, so that would not be. um, do you know anything about yaw?
I do not know very much about roll, pitch, and yaw. Um, I am more on the mechanical engineering side, particularly on the mechanics material side. So I don't do a whole lot with kind of flying vehicles and aerospace.
You mentioned airplanes, so I had to ask. So, what is your favorite class to teach on campus right now?
I don't know as though I have a favorite of the ones I've taught so far. I do.
Those three go with each other, technically.
How do they go with one another? So they're all based on mechanics and materials. So basically, how materials behave, typically under load. So the materials and manufacturing processes is you're looking at basically how materials are structured, starting at like the atomic level and building up into large materials, and then how we manufacture those materials and how those manufacturing processes affect their end material properties and how they behave. And then obviously elasticity and fraction mechanics are how materials behave when we actually put load on them and deform them.
You mentioned a couple of like real world examples, like you use this table in an airplane, and are you involved in any sort of like research outside of campus or any industry? Or anything?
Yes, definitely. So they're definitely involved in research, both kind of here at UAH as well as some of my old research colleagues that I was working with at Ohio State University. A lot of my prior research has been on in the aerospace field on aircrafts. So basically looking at how airplanes might fail and how components might break apart and fracture, and then trying to understand how those materials are going to behave under those conditions so that we can design airplanes safer.
So you're doing research on airplanes. Are you like working for a specific company?
So that previous research was sponsored by the Federal Aviation Administration, that's the FAA, and it's a big project that involves many different universities as well as different private companies as well as government research centers like the NASA Glenn Research Center up in Cleveland. So lots of different people working on that project.
Is there a way for students to get involved with that? / can you give me a job?
I cannot currently give you a job immediately, unfortunately, no. But if students are interested in doing research just on mechanics and materials-based things, certainly they can get involved. The best way is to just contact me. Information is on the UAH websites, so get in touch and we will see what kind of research we can do.
Awesome. What do your most successful students typically have as qualities, or like what do they do in the classroom?
Sure. I think one quality they often have is discipline. So just being an engineering student is difficult and challenging, right? It's very technically challenging. There's a lot of work, a lot of material that you have to kind of really work hard at to understand. So it takes a lot of discipline to basically put in that time and effort to do that. And kind of starting with little things like attending class regularly, making sure you have set time during the day to study and work on the homework and work on the course material. So discipline is definitely a big thing. I would say curiosity is another one. Just having that desire to know more and to kind of try and figure out and understand why things work the way they do is a very big part of being a successful student and a successful engineer. And it also would say some level of self-awareness, because everyone has things that they are kind of naturally good at and things that they're naturally not quite so good at. And so understanding kind of where your personal strengths and weaknesses are, and understanding, I need to put more effort and time over here in this area where I'm not quite so good at, so I can get better at that, and that's going to make me a better student overall and a better engineer overall.
What are some things that a student can do to help increase their strengths in areas that they might not be so good at?
Yeah, I would say a big thing is just talking to people, so talking to your peers and students, particularly if you have someone who's really good at an area that you're not quite so good at, as well as talking to your professors and instructors. We have office hours where we make ourselves available to students. So please come and talk to us and ask for advice and see what the best path forward might be.
Is there something in particular that makes a student stand out in your classroom to you?
I feel like I've had lots of different students who've stood out for lots of different reasons.
Okay.
So it's very difficult to boil it down to, there is this specific quality. I think, but I think most of the ones that I've kind of stood out are the ones that um, are kind of willing to put in the work, if that makes sense. Like I said, engineering is very difficult, and it's difficult for everyone. Every student who takes an engineering course is going to be challenged by it. And so understanding that and being, not being afraid of that effort and putting in that work and being willing to do that, I think is definitely something that makes students stand out and definitely is helpful for being a successful engineer.
Do you have any hobbies or interests outside of engineering?
No, just kidding. Yes, I do. No, my entire life is not consumed by engineering. I enjoy the outdoors, so trying to find some new fishing spots in Huntsville since I just recently moved down here. As well as there's lots of good hiking around here and some camping. That's always fun. I do martial arts, so I did karate back in Ohio, and I have started doing taekwondo here at the University Fitness Center, as well as aikido and some boxing.
Is there a favorite body of water near here that you like to go to?
Not that I've found yet. I'm
Okay.
still trying to figure out the good spots.
All right.
I've heard there are some good spots in the Arsenal. I do not have Arsenal access, and I
Yeah.
haven't found any holes in the fence yet to slip in there. It's probably not a good idea.
Probably not. Probably not. Have your hobbies and interests, do you feel like that they've helped you in your engineering career?
I feel like there is some spillover between the engineering and the hobbies and the engineering, that they both kind of help one another. I feel like it's also, yes, when my fishing poles break because I have a very large fish on, I know the fraction mechanics of why they broke.
There's little cracks in every like little piece of that fishing pole, right?
Yep, in the fishing pole, in the fishing line, yep, it's got little micro cracks.
Yeah.
So yeah, I can blame it on the people who manufactured put those
Yeah.
cracks in there. Yeah, there's a little bit of overlap between them, but I think it's also good to have hobbies that are not your work and get a little break from it as well.
Mhm. If you were to rank all of the types of engineering, I want to know who would be at the top and who would be at the bottom.
I am not doing that because I have to. Because all areas of engineering are important, and also because I don't want to make the other engineers angry.
All right. Well, thank you for avoiding my question. Do you have any advice for students who are coming into college and trying to choose what type of engineering to go into?
Sure. I would say probably the best thing is just to talk to people. So talk to other students who are a little further ahead in their studies about what it's like to be studying those types of engineering. Talk to professors and instructors. Try and talk to people who are actual engineers working in those fields, and see what it's like and what their kind of day-to-day jobs are, and the things that make successful engineers in that field versus the other fields. And just try and get all that information. Just talk to people.
Do you have any advice for students coming to college in general?
Yeah, so college is usually a pretty big life change. You're often, a student is moving out, living on their own for the first time. And so I think it's important to just kind of get the basics of just having a good routine down is probably one of the best things you can do right away, because if you get that down right away when you first start college, it's going to help you throughout your entire college career. So that's things like having a good daily schedule, so having times for studying as well as breaks and exercise and things like that. Making sure that you have good sleep habits so that you're getting enough sleep and that you're getting regular sleep, going to bed and waking up at roughly the same times. As well as eating healthy, exercising regularly, or having kind of healthy ways to de-stress. All those kind of little incidental things, but that come together and really will help make you successful.
Are we going to see you at the engineering showcase next week?
Yes, I will hopefully be there.
Awesome. Well, we will see you there then. Thank you very much for your time.
Thank you.
PhD.
So with the doctors on campus.
Academia just does something to doctorate. You can't enjoy beverages.
No, you just need you just can't dilute the coffee down, because then you're not getting as strong of an effect. So all the creamer and milk and everything, man, just dilutes. It's just needed as strong as you can possibly get.